Hello everyone. Today we are going to solve Feb March 2024 QP42 theory paper. So let's start. Question 1. Iron ore contains iron 3 oxide. A blast furnace is used to extract iron from Fe2O3. Equation for some of the reactions in the blast furnace are shown. So few reactions are already given. Equation 1 shows the combustion of carbon in the blast furnace. Name the substance which provides the carbon for this reaction. So, carbon is being provided from coke. State the purpose of combustion of carbon in the blast furnace. So we need to heat the blast furnace, okay, and when carbon reacts with oxygen, it's a exothermic reaction, so that releases heat in the blast furnace, hence to provide heat, to heat up the blast furnace. Iron 3 oxide in iron ore is converted to iron when it reacts with carbon monoxide in the blast furnace. Calculate the percentage by mass of iron in iron 3 oxide. So first of all, we need to know how many iron atoms do we have. So we have 2 iron atoms. So 2 into its atomic mass, which is 112, and then we have to find the MR of whole formula. So MR of whole formula is 2 into 56, plus we have 3 oxygen atoms into 16. So the total is 160. Therefore, 112 upon the MR of the formula into 100. This will give me 70. State the name of iron ore which consists mainly of iron 3 oxide. We have learnt only about one ore, that is hematite. Next, describe how carbon monoxide is formed in the blast furnace. So carbon dioxide reacts with carbon and hence it forms carbon monoxide. So it is by reduction of carbon dioxide. Next, write the symbolic equation for the reaction that occurs when iron 3 oxide is converted to iron in the blast furnace. This is an important reaction. Many times it is being asked. So, Fe2O3 plus 3CO will give me 2Fe plus 3CO2. Next, name the chemical process which happens to iron when iron 3 oxide is converted to iron in the blast furnace. So here we are using carbon or carbon monoxide, and this method used is known as reduction method. Next, state the type of reaction shown by equation 2. So first of all, let us see what is equation 2. You can see that equation 2 is calcium carbonate giving us calcium oxide and carbon dioxide. So one compound, when it is decomposed to form 2 or more simpler compounds, is known as thermal decomposition. It is thermal decomposition. Next, explain why the reaction in equation 3 can be described as an acid-base reaction. So reaction in equation 3, if you see, we have calcium oxide reacting with silicon oxide to give us calcium silicate. Now, calcium oxide is a basic oxide. So, calcium oxide is basic oxide and silicon oxide is acidic in nature. Hence, it is known as acid-base reaction. Next, state the chemical name of SiO2. So it is named as silicon 4 oxide. Next, give the common name of CaSiO3 when it is formed in the blast furnace. We have to write the common name. This is commonly known as slag, and its chemical name is calcium silicate. Next, aluminium cannot be extracted from its ore using a blast furnace. State why aluminium is not extracted from the ore using a blast furnace. We know that aluminium is extracted using electrolysis. Okay, and why it is so? Because if you see the reactivity series, aluminium comes above carbon. So we have sodium, potassium, calcium, magnesium, aluminium, and then we have carbon. So anything which is above carbon, they all are extracted using electrolysis. Okay, so we can write that aluminium is more reactive than carbon. Name the process used to extract aluminium from its ore. So it is extracted using electrolysis. Next, both iron 3 oxide and aluminium oxide contain metal ions with a 3 plus charge. Write the electronic configuration of Al3 plus ion. You can see that here aluminium is having a 3 plus charge. Okay, aluminium atomic number is 13. Now when the it is having a charge, a positive charge on it of 3 plus, meaning 3 electrons are being donated. Okay, so how many are remaining? Only 10 are remaining. So the electronic configuration will become 2 comma 8. Next, deduce the number of protons and electrons in Fe3 plus ion. Now again we have to find the number of protons and electrons in Fe3 plus. Okay, so you have to use periodic table here, and you have to first find out atomic number which is equal to proton number. Okay, so atomic number of iron you will get from periodic table, which is 26, and we know that number of electrons, number of protons is always electron equal to number of electrons, but we have a 3 plus charge here, meaning 3 electrons are being donated. Okay, so 26 minus 3 will give you 23 electrons here. Okay, yeah. So we complete question 1 here. Next is question 2. The elements in group 7 of the periodic table are known as halogens. Halogens can form halide ions. Identify the halogen with the lowest density at room temperature and pressure. So for that we should know the trends in group 7. Okay, we have to name the halogen with the lowest density. So the first two elements, that is fluorine and chlorine, they both are gaseous in nature. Hence we can write fluorine here. State the appearance of bromine at room temperature and pressure. So bromine is the only liquid non-metal. Okay, and it is reddish brown in color. So it is a red brown liquid. Use the periodic table to give the symbol of the halogen with the highest atomic number. So now here for that we will have to refer periodic table. So yeah, for that we will have to go to halogens, that is this, and in halogens if you see, the one which is with the highest atomic number is this, which is tennessine, TS. So I'll write here. Deduce the number of occupied electron shells in an atom of this element. So again we have to use periodic table for that. Okay, now if you see, if you know how to read periodic table, the group number tells us about how many electrons are present in the outer shell, and period number tells us about how many electron occupied shells are there with the element. So here from helium, this is my first period, second, third, fourth, fifth, sixth and seventh. Okay, so the answer here, the number of occupied electron shells is total 7. Next, bromine molecules have covalent bonding. State what is meant by the term covalent bond. So what is covalent bonding? It is sharing pair of electrons between two atoms. So it is sharing pair of electron between two atoms. Next, name one halide ion which bromine molecules can displace. So we know that as we go down the group in group 7, the reactivity decreases. Okay, so the element which bromine can displace is either iodine or any element which is below bromine you can consider. So again we'll have to check periodic table. Now below bromine we have iodine, acetine and tennessine. You can write name of any one of this element. So we'll write here iodide. Okay. Explain why bromine can displace the halide ion in D2. It is because bromine is more reactive than iodine. So we know that as we go down the group in group 7, the reactivity decreases down the group. Okay, so bromine will be able to displace all the elements which are below bromine. Next, name a halide compound which can be used to detect the presence of water. Okay, so the halide compound that we have that can be used to detect the presence of water is anhydrous cobalt chloride. If you write only cobalt chloride, you might get only 1 mark because we have to detect presence of water. It need to be anhydrous. Next, calcium chloride is an ionic compound. It is clearly mentioned. We have to complete the dot and cross diagram here. Okay. Now in this case, we have to always understand that we can use periodic table if you are directly not able to understand what will be the charge and how many shells you have to draw. Okay. So calcium has atomic number 20. Okay, so its electronic configuration will be 2882, whereas chlorine is having its electronic configuration as atomic number as 17. So the electronic configuration is 2, 8, 7. Okay, now we have two chlorines here. Okay, and we know that chlorine requires only one electron. Okay, so calcium is supposed to donate its two electrons, one each to the chlorine. So calcium, when it donates electron, will have a +2 charge, whereas both the chlorine will have a -1 charge because they are accepting electron. Okay, now if you see here for calcium, they have already completed the first and second shell. The third shell is still remaining. We have to draw that. So let us complete the shell here. Similarly, in chlorine, we have to draw one more shell where there will be 7 electrons of chlorine and 1 electron of calcium. Next, aqueous lead 2 ions are added to aqueous chloride ions. A white precipitate of insoluble lead 2 chloride is formed. Name a lead 2 compound which can be used in this reaction. So you have to remember the solubilities of the salts, that is sulfates, nitrates and all the halides, either chloride, bromide or iodide. Okay, you have to remember that all the nitrates of all the elements are soluble. So we are gonna use here lead nitrate. Okay, so we will be using lead 2 nitrate. Write the ionic equation for this reaction and include the state symbols. Now this question is very much important. Whenever they ask any question based on precipitation reaction, the ionic equation is always asked. Students always gets confused in this type of reaction where they feel that they have to write the complete reaction of the reactants and the products, but they have asked you to write only the ionic equation. If you read the question, they have already given you the product that is formed, which is lead 2 chloride, that is PbCl2. So you are always supposed to write the ionic equation of the product only, that is the precipitate. Okay, so here it will be Pb2 plus we have 2 chlorine atoms, so 2Cl minus, which is gonna give us PbCl2. Okay, so this is the ionic equation. Now we are supposed to write the state symbols. Now, how to understand that what will be the state symbols? If you read the question again, they have said that aqueous lead 2 ions are added, meaning the compound which lead compound which is being used is in its aqueous form, so we'll write AQ. Again added to aqueous chloride ions, meaning the chloride compound which is used is also in its aqueous form. And we have got a white precipitate. Precipitate is always in the solid state, so the PbCl2 will have a solid here. Okay, so this is how we are supposed to write this ionic equation and score 3 marks. Next, name one other insoluble chloride. Okay, so we, as I told you, that you will have to remember the solubilities. So we have silver chloride. Silver halides are insoluble. Okay, whether it is silver chloride, silver bromide, or silver iodide. So we complete question 2 here. Next is question number 3. This question is about acids, bases, and alkalis. The table is being given where they have mentioned the substance and the pH is also given. First of all, first question is define the term base. So bases are defined as proton acceptor. Next, state what is meant by the term alkali. So alkalis are known as soluble bases. So we are going to write the same thing. They are soluble base. Next, thymolphthalin is an indicator. State the color of thymolphthalin in NaOH. Now, thymolphthalin gives blue color in bases. So, we know that NaOH is a base, that is alkali, we'll write blue. And next is CH3COOH, which is ethanoic acid. Thymolphthalin is colorless in acids. So, we'll write colorless here. Next, use the information in table 3.1 to identify the substance with highest concentration of H plus ions. Explain your answer. We have to understand that the one which is having highest concentration of H plus ions, meaning the acid has completely dissociated and we have more number of H plus concentration. Okay, higher the concentration, lower is the pH, and the only substance we can get here is HNO3. Okay, so the substance with highest H plus ion concentration is HNO3, and the reason is it is having a low pH. Okay, next, name an indicator which can be used to identify the substance with the highest concentration of H plus ions. So we know that we can understand the color change and we can just identify whether a substance is acidic or basic using methyl orange, thymolphthalin, or litmus paper, but we cannot find out the pH. For pH we have a different indicator which is known as universal indicator. Next, complete the equation to show the dissociation of ethanoic acid in aqueous solution. So we should know that ethanoic acid is a weak acid, okay, and therefore it will have a reversible sign here, okay, and CH3COO minus plus H plus. This is the dissociation of ethanoic acid. Next, write the ionic equation which represents a neutralization reaction between any acid and alkali. So, what is the neutralization reaction? Neutralization reaction is when an acid and an alkali or acid and a base react to give you salt and water. Okay, so the ionic equation here will be H plus OH minus, giving us H2O. Next, dilute nitric acid reacts with aqueous calcium hydroxide as shown. They have also provided us with the equation. 20 centimeter cube of 0.0150 mole per dm cube of calcium hydroxide reacts with 25.0 centimeter cube of nitric acid. Calculate the concentration of HNO3 in grams per dm cube. Calculate the number of moles of calcium hydroxide used. So if you see, they have given us values for calcium hydroxide, which is 20.0 centimeter cube of 0.0150 mole per dm cube. Whatever is given in centimeter cube is volume. Whatever is given in moles per dm cube is your concentration. So we are supposed to use the formula N is equal to C into V upon 1000. So it will be 0.0150 into 20 upon 1000. So the answer you will get here is 3 into 10 raised to minus 4. Now many of you might only use the formula N is equal to CV. Okay, in that case you first convert the volume from centimeter cube to dm cube. Okay, if you do that, don't add 1000 in your formula. But if you are not converting centimeter cubes to dm cube, please add 1000 in your formula. It will automatically convert and give you the correct answer. Next, determine the number of moles of nitric acid which react with calcium hydroxide. Now here, to find the moles of nitric acid, again we can use the same formula, but we are supposed to find the concentration. So volume is only provided to us. Okay, so how are we supposed to do this? For that, we will take a ratio of HNO3 is to calcium hydroxide. You can see that there is a stoichiometric coefficient written in front of HNO3, which is 2, and there is nothing in front of calcium hydroxide, which is 1. So HNO3 is to calcium hydroxide is 2:1 ratio. We have to find moles of HNO3, so we'll write X, and we already have found out moles of calcium hydroxide, which is 0.0003. We will cross multiply. So it is 2 into 0.0003, okay, which is gonna give us 0.0006. Next, calculate the concentration of nitric acid in moles per dm cube. So we need to use the same formula here, okay, that is N is equal to C into V upon 1000, but we are gonna rearrange it as we need to find concentration. So C is equal to N into 1000 upon V. Now, we have just found the moles of nitric acid, which is 0.0006 into 1000 upon V. Volume of nitric acid is already given, which is 25.0. So, it is 25. So, after calculating, we will get it as 0.0240 moles per dm cube. Okay. Now, lastly, we have to find the concentration in grams per dm cube. So the concentration which we have found in moles per dm cube, we have to multiply it with mR of nitric acid. So first you will have to find mR of nitric acid, which is for hydrogen it is 1, for nitrogen it is 14, and for oxygen it is 3 oxygen atoms, 3 into 16. Okay, which is gonna give us 63. So 0.0240 into 63 will give us 1.512 grams per dm cube. This is your simple calculation of moles. If you go stepwise, you will not get confused. Next is question number 4. The equation for the reaction between methanoic acid and ethanol in the presence of a catalyst can be represented as shown. They have given you the equation, okay, and delta H value is also provided here. X represents the ester is formed. In equation, methanoic acid is represented by the formula HCOOH. Name this type of formula. Okay, so this type of condensed formula is known as structural formula. It is known as structural formula. Write the empirical formula of methanoic acid. So already the formula of methanoic acid is given. We have to write the empirical formula. For that, first of all, we have to count the number of atoms given here. So we have only one carbon atom. We have two hydrogen atoms and we have two oxygen atoms. We cannot simplify it further. So CH2O2 becomes the empirical formula of methanoic acid. Next, name and draw the displayed formula of ester X. So here if you see, we have methanoic acid and ethanol. From methanoic acid, we are supposed to remove this OH, and from ethanol, we are supposed to remove the hydrogen. Whatever we have, we are just gonna connect these two together. Okay, so we have to make a displayed formula here. Okay, so we'll write down. So it is H. Displayed formula, you always show all the bonds. So C double bond O. Okay, we have removed the OH. Now we have to write this CH3 CH2O. I'm gonna flip that and write down. So I'll put a bond here, then O, then I have carbon with two hydrogens, then again I have a carbon with three hydrogens. So this is my structure of ester. Okay, and the name of the ester will be, because I have used ethanol, so it will be ethyl, and I have used methanoic acid, so it will be methane, and for ester we name as O8, so it is ethyl methanoate. Next, the reaction is reversible and reaches an equilibrium within a closed system. State what do you mean by the term closed system. So what is closed system? Nothing can enter or escape. Okay, nothing can enter or escape. Next, state two characteristics of an equilibrium. So first, the rate of forward reaction is equal to rate of backward reaction, and second, concentration of reactants and products is constant. Don't write equal, you can write same or you can write constant. Okay, the concentration of reactants and products is never equal, it stays the same. Next, complete the table to show the effect, if any, on the concentration of X at equilibrium for each change of the condition. So I'll write the equation here, which was HCOOH plus CH3 CH2OH to give us X plus H2, right? Now we have to pay attention on X, the concentration of X. Okay, so first if the temperature is decreased, now for the temperature we have to know that what was my forward reaction, whether it is exothermic or endothermic. For that, let us check the reaction. As I told you that they have given us the delta H value, and the value is minus 29.5. Whenever the delta H value is in negatives, meaning the forward reaction is exothermic. So the backward will be endo. When the forward reaction is exothermic and when we decrease the temperature, okay, the concentration of X is gonna increase here. Anyways, the reaction which is exothermic, it is gonna release the energy. Okay, it does not require the energy. So if we decrease the temperature, it is gonna increase the yield. Next, concentration of methanoic acid is decreased. If we decrease the concentration of one of the reactant, ultimately the product which needs to be formed, that is the X, its concentration will also decrease. Concentrations of both the reactants, that is methanoic acid and ethanols, are decreased. Definitely if the concentration is decreased, you will get less amount of the product formed, hence the concentration of X is also gonna decrease here. The catalyst is removed. Now, catalyst actually does not play any role in shifting the position of equilibrium or in the yield of the product that needs to be formed. Catalyst always helps to increase the speed of reaction and does not shift the equilibrium position or does not change any concentration. So, there will be no change. Next, question 5. Butane and but1-ene are colorless gases at room temperature and pressure. Suggest why but1-ene diffuses quicker than butane. In this case, you have to write the formula and find out the molar mass for both of them. Okay, you can simply write the molecular formula or the structural formula and calculate the MR for both. You will see that butane is having a greater MR than but1-ene. Okay, so you can simply write down that but1-ene has lower relative molar mass. Okay, identify the products formed when butane undergoes complete combustion. When alkanes undergo combustion, we get products, that is carbon dioxide and water. Next, C. One molecule of butane reacts with one molecule of chlorine in presence of ultraviolet light. During the reaction, one hydrogen atom in butane is replaced by one chlorine atom. Name the type of reaction which needs ultraviolet light. Okay, so the reaction that requires light as a reaction condition is known as photochemical reaction. Next, state the purpose of ultraviolet light during this reaction. So the UV light is actually providing activation energy. It is providing activation energy. Name the type of reaction which takes place when one atom of chlorine replaces one atom of hydrogen. Okay, this is known as a substitution reaction. When one atom is being replaced by another atom or a group of atoms, this is known as substitution reaction. Determine how many different structural isomers can form during this reaction. Okay, so there can be only two structural isomers, that is 1-chlorobutane and 2-chlorobutane. This is the only possibility that can form. So we have only two structural isomers forming. Next question, D. When but1-ene reacts with steam, two possible products form. Identify the type of catalyst which is used in this reaction. So when but1-ene, that is alkene, reacts with steam, the reaction is known as hydration reaction. Okay, where alcohol is formed and the catalyst used here is acid catalyst. Okay. So, name the products and draw the displayed formula of the two possible products. So, here one is butane 1 all and the other possibility can be butane 2 all. We have to draw the displayed formula. So, we have to draw first of all 4 carbon atoms, 3 and 4. Okay, and then we will draw bonds everywhere. So 1 also will put OH here, rest all will be hydrogen, hydrogen everywhere. Same goes with the second formula. There are 4 carbon atoms, 1, 2, 3 and 4, 1 hydrogen, and at my second position I will draw OH here and rest all will be hydrogens drawn. Next, But1 undergoes polymerization. State the type of polymerization but1 undergoes. We have to remember that alkene always undergoes addition polymerization. It always undergoes addition polymerization. Draw part of the polymer molecule to show three repeat units. We have to draw three repeat units of but1. Okay. So for that, first of all, we need to rearrange but1 in its monomer form. Okay. So we have already drawn the structure of but1 here. Let me draw it once again, which is CH2 double bond CH, single bond CH2 and CH3. Okay, we have to remember that the double bond or the polymerization always happens between the carbon carbon double bond. So this carbon carbon double bond is important for us, so we'll draw that. So we'll draw carbon carbon double bond here. To my first carbon atom, I have two hydrogens, so I will draw two hydrogens here. For my second carbon atom, I have one hydrogen, and other groups that I have is CH2, CH3. So I will write here CH2, either I can write C2H5, oh sorry, either I can write C2H5 or I can write CH2 CH3. Okay, so this is my monomer. This is my monomer. I have to draw three repeat units of the same. Okay, so here I will be drawing three repeat units. So here this is my first unit, this is my second unit, this is my third unit. So when they say that we have to draw three units, in total there should be six carbon atoms. Okay, and bond extensions, and then I will be drawing the remaining groups here. So it's HC2H5, HC2H5, hydrogen, 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 and hydrogen everywhere. Okay. So this is how you are supposed to find the polymer. So whenever they ask you to draw a repeat unit, first rearrange and make a monomer, and then repeat the same monomer just by converting the double bond to single bond and show bond extensions on both the sides. I hope you have understood whatever we have done in this paper.